All right, we're going to cover some quadratics, as we can see listed: standard form, general form, solving, finding the roots and zeros. What is the determinant? How do we find it? What does it mean? The vertex. How do we find the vertex? We have two different ways. And then sketching some rough graphs of these quadratics using the above information. First off, this is written in standard form. Some people call it general form. Most agree that this is standard form. We're going to write this into a general form, which is the, we're going to expand this out where we have the ax squared plus bx plus c. This standard form is of the a times x minus h quantity squared plus k. That's our f of x equals that, where it gives us some useful information. But first, let's convert this into a general form. We're going to expand this, x plus 1 quantity squared. So we'll have negative 2 times x squared plus 2x plus 1 plus 3. Distribute the negative 2, negative 2x squared. Let's move this up. Minus 4x minus 2 plus 3. We'll combine our like terms. Negative 2x squared minus 4x plus 1. This is our general form, where our general form right here, where we have a x squared plus bx plus c, our constant term. So highest exponent first of the variables, highest exponent first, followed by the, in descending order, we'll line them up thereafter, with our constant term at the end, because this is really x to the 0, x to the 1, x to the 2. If there was a, if this was a cubic with an x cubed, we'd have that first. Our leading coefficient is whatever is in front of the x squared. That's our a. We want to identify some of these. We want identify a to be negative 2. B is our second coefficient, which is negative 4. And C, our constant term, is positive 1. It is oftentimes helpful to identify what the opposite of B is. The opposite of B in this case is going to be positive 4. What is the determinant? Now we've identified what A, B, and C are, and we've put it into our general form. What is the determinant of this, and then what is it used for? Well, the determinant, the form of the determinant is, like we had above, b squared minus 4ac. Now, if the determinant is negative, then there are no real roots. In fact, there are 2 complex roots. In other words, the graph does not cross the x-axis. If it is 0, if the determinant ends up being 0, there is exactly 1 real root, and it has a multiplicity of 2. And then if the determinant is positive, it has 2 real roots. All right, let's find out what the determinant is here of our negative 2x squared minus 4x plus 1. So our determinant, b squared minus 4ac. b squared is, well, that's negative 4 quantity squared, minus 4 times a, which is negative 2, times c, which is 1. This is 16 minus 4 times negative 2 times 1. That's a positive 8, which is 24 today. Since it's positive, we have 2 real roots, meaning that it's going to cross the x-axis 2 times. At this point, we could get a general idea of a graph of this. So let's look at that a little bit. We know it's going to cross twice, and we know that since that is a negative 2 as a leading coefficient, we know it's going to be opening down. The other item that we haven't discussed yet, is the vertex. When we start in standard form, the vertex is given to us by the h and the k. So the vertex is hk. In this case, h is positive 1, or actually, this is x minus h. X is negative 1, and k is positive 3. It's negative 1 because the form we're looking for is x minus h. Well, this is an x plus 1, not a minus. So this is really minus a negative 1. That's the format. X minus something is x minus a negative 1, which turns into a positive. So in this case, the vertex is going to be negative 1, comma 3. We can graph that. Negative 1, comma 3, negative 1, 1, 2, 3. There's our vertex. And it's opening downward because, how do we know that? Well, the leading coefficient, which is our a, is negative 2. So it's going to go down this way. That's a rough sketch. Next, we're going to look at where it crosses the x-axis to get this a little more precise. How do we do that? Well, there are a couple of ways. We have negative 2x squared minus 4x plus 1, which is the same as the negative 2 times x plus 1 quantity squared plus 3. In this general form, first off, to find the roots or the zeros, the solutions where it crosses the x-axis, we're going to want to factor this. We're going to set it equal to 0. So if we have 0 equals negative 2x squared minus 4x plus 1, ideally we want to find a factor and use the zero product rule and set each factor equal to 0. That'll give us the roots that we're looking for. Well, we'd have to have a negative 2x and an x for our first term here. Our last term we'd have to have a 1 and a 1. But no matter how we slice it, negative 2 times 1 plus a 1 times x, we're going to have a negative 3x or a negative 1x, or we're going to have a 1x or a 3x. We're never going to have a negative 4x. So this cannot be factored in our usual methods. So we have two other choices. We can use completing the square, which completing the square, I know it's usually your least favorite option, is we're going to get rid of, this is set equal to 0. We're going to move the 1 to the other side. So we have negative 1 equals negative 2x squared minus 4x. Then we're going to get rid of the leading coefficient. We're going to turn it into a 1. So we're divide everything by negative 2. Dividing everything by negative 2, we have a 1/2 over here, x squared, and then we have a 2x right there. Completing the square, we're looking for this term. We're going to cut the 2 in half and then square it. Half of 2 is 1. 1 squared is 1. So we're going to add 1 to this spot right here. But because it's an equality, what we do to one side, we have to do to the other side. So we're going to add a 1 over here as well. This becomes 3/2 equals, then we can factor this directly to x plus 1 quantity squared. Taking the square root of both sides, we have, let's see, is that correct? I'm sorry. Yeah, square root of both sides, square root of 3 over the square root of 2, and that's plus or minus, equals x plus 1. Subtract 1 from both sides, you have negative 1 plus or minus square root of 3 over square root of 2, which if you rationalize the denominator, you'll have negative 1 plus or minus the square root of 6 over 2. Well, hang on to that for a minute. Completing the square, if you don't like that, there's another option, and that is using the quadratic formula. What's the quadratic formula? There was a negative boy who couldn't decide if he wanted to go to a radical party, but the boy was squared, and he missed out on 4 awesome chicks. It was all over by 2 a.m. that's our general formula for our quadratic formula. And if we plug our numbers in that we a, b, c, and negative b into this, we'll have x equals, negative b was 4 plus or minus. We found the determinant earlier, and that was 24. So I'm just going to put a 24 there, all over 2 times a. A was negative 2, so this is negative 4. If we simplify this down, we're going to get 4 over negative 4, plus or minus. I'm going to break this fraction up into 2. Square root of 24. Well, this is, the square root of 24 is, what is that, 4 times 6? 4 times 6, where 4 is a perfect square. Well, we take the square root of 4, and that's a 2, and 6 is left over inside the radical, over negative 4. Reducing this, we have negative 1 plus or minus, this is a negative 1/2, so it's just negative 1/2, and root 6, so square root of 6 over 2. The same thing we have from completing the square. So both of those are sufficient answers, but what are they really? How do I graph that? Well, if you pull out a calculator, and you can see that an estimate would be 0.2 and negative 2.2, which is great because on our graph above, the vertex and the axis of symmetry, the x value is negative 1. Well, negative 1 happens to be exactly halfway between 0.2 and negative 2.2. It's 1.2 away from both of those. So the vertex is halfway between that 0.2 and the negative 2.2. If we drew that to scale, we might get a little bit closer, but this is good enough for a sketch. We could label the points to be more precise. All right, what else do we need to cover? We have gotten the standard form and general form. We've solved finding the roots or the zeros using factoring. It didn't work on this one, it was prime, so we went to quadratic formula and completing the square. We looked at the determinant, what it meant. The vertex was the h and the k. We sketched a graph. Let's look at the other form of the vertex, negative b over 2a, and then we'll plug that back in. From our general form, looking at this right here, we want to find the vertex. I'm claiming this is negative b over 2a, comma, and then we plug the negative b over 2a back in for an xy point. It should be negative 1, 3. Well, what is negative b over 2a? Well, negative b is 4. 2a is negative 2 times 2 is negative 4. So it's the 4 over negative 4. Let's write that down. 4 over negative 4 is negative 1. Well, what about this business here? Well, we're going to take the negative 1 and we're going to plug it back in here. So we're going to have negative 2 times negative 1 squared minus 4 times negative 1 plus 1. What is this? This is negative 2 times 1, so it's negative 2 plus 4 plus 1. What do we have? Negative 1 plus 4 is 3. Oh, that's good. It worked out. So when we plug the negative 1 in, back into the function, we're going to get the output. If negative 1 is the input, 3 is the output. Negative 1 is the input, 3 is the output. Here we're taking that right from the standard form. This one we have to derive from our general form. For the questions, we'll see you in class.